Hello, Mr. Johnson here. We're preparing for types of chemical reaction lab, and the first part we're going to do is concerning double displacement, where we mix a number of solutions. And a solution looks like water. Okay, for example, here is a potassium chloride solution. It'd be written KClAQ because AQ means dissolved in water. It just looks like water, okay? Looks like water. Uh, this is salt. And potassium chloride looks just like salt. As a matter of fact, many ionic solids look white like salt, and they dissolve to give solutions. If something dissolves, it's soluble. If it doesn't dissolve, it's insoluble. Okay, so now we're going to mix the solutions. I'll start off with some distilled water. I'll just put a drop in each of the distilled water boxes here. Distilled water is water that is just water, has nothing in it. It's pure. Okay, and then I'm going to add some tap water. I'm just doing it. This is probably the most efficient way to do this. We're going to put a drop of each of the solutions in in a box, and then we're going to put another drop and mix them. Now we'll do sodium nitrate. Here's sodium nitrate. There it is. And then now I can mix the sodium nitrate here and here. Now I'm done with the sodium nitrate. I should have done the other drop of the tap too. I'll do that in now. Tap going with distilled. And what we're looking for is a precipitate. Okay. A precipitate is when the solution wouldn't be clear but it appear cloudy because a solid would fall out. Okay, now I'm going to do sodium iodide. Whoops, sorry, I bumped you there. Sodium iodide. Here it comes. And then we'll do sodium hydroxide. Here it comes. So far, no precipitates. Then we'll do copper sulfate. Copper sulfate's kind of a bluish solution. It's the only blue, it's the only colored one we have. Here comes the copper sulfate. Then I'm going to go down here. Boom, 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 boom. And this time we actually do have two precipitates. We got a bluish precipitate with copper sulfate and sodium hydroxide, and a brownish precipitate there with sodium iodide and copper sulfate solution. Now we'll go with potassium chloride. Here's potassium chloride. And then we've got one more. We've got lead nitrate, lead 2 nitrate. There we go. Lead 2 nitrate. There's a precipitate. Another one. Ooh, wow, that's a beautiful one there, a beautiful yellow one. Looks like this one's giving more precipitates than the others. So, where do we get precipitates there? Well, we got one with lead nitrate and potassium chloride. We got one with lead nitrate and copper sulfate. One with lead nitrate and sodium hydroxide. Those are all white. There's a yellow precipitate of lead nitrate with sodium iodide. And there's also a precipitate with tap water. Okay, so we actually did the reactions now, and after we've done the reactions, then we have to write equations for where we saw the precipitate. Okay, there is a precipitate because one of the new combinations is insoluble, results in a solid that falls out of solution. So we had 7 precipitates. Now we don't have to write one for the tap water because we don't really know what the formula is for tap water, although we can probably say the tap water must have had some chemical in it that reacted with the lead nitrate. But for the other 6, we need to write equations. So I will show you how one would work. Okay, we did have a reaction with the sodium iodide solution. So we write NaIAQ, and it reacted with the lead 2 nitrate solution. Write that like this. Okay, now I'm running out of room, so I'm just going to continue it on below here. And that produced, okay, so we did have a reaction. We have, now there's 2 possibilities here. Okay, the sodium, well, first of all, it's like square dancing, if you remember. Boys go with girls in the square dancing. 2 boys don't go together. In the same way, a positive element goes with a negative element. Okay, so when they switch partners, a positive doesn't go with a positive. For example, the sodium would never go with the lead because they're both positive. They're both boys. And the iodine would never go with the nitrate because they're both negative. So the sodium will go with the nitrate because that's the only possibility here. So we got Na plus 1, and nitrate is a minus 1, so it's just NaNO3. And then the other is going to be Pb, which in this formula is a plus 2, and I is a minus 1. So we've got PbI2. Okay, and then we have to balance it. We got 2 nitrates, so we need 2 here to balance the nitrates. Put a 2 there, and that'll balance the sodiums and the iodine, and we have a balance. But now the hard part really is figuring out which one of these is a precipitate. Okay, one of these is going to have a Q by it because it's still dissolved, and one of them is going to have S by it because it's a precipitate. The way we know which one's which is we consult page 280. Page 280. Not 280, I'm sorry. 860. Page 860 of your book. And on page 860 there's a solubility chart. Okay. On the solubility chart, a capital S means soluble. And anything else, any other mark there, means insoluble. Okay, so it has a capital S, it's going to have a Q. If it has anything else there, like A or P or a line, hyphen, that means it's insoluble and it's going to be the precipitate. So when we go and look at the chart on page 860, we see that sodium nitrate has a capital S by it, so it's going to be soluble. And therefore we're going to put an AQ there. And if we look at the chart on page 860, we'll see that lead and iodine, when they go together, it says P. Okay, that means that is going to be a solid. It's going to be insoluble, so we'll put an S there. Another way of indicating a precipitate is an arrow down. Okay, you'll see that in some cases. So you have to do that with all of the reactions that happened, except for the tap water. Well, I did 1, so that means there's 5 left.